You know how when it's time to talk about applying whatever topic that we're talking about, in this case rational functions, I like to try to find quote unquote real world examples, right? So I found some examples for you. We're going to talk through them today. As far as real world goes, these are examples of how rational functions are used. Now, are the construction workers at this job using rational functions? Probably not. The people planning these jobs, maybe, but maybe it's built into the computer programs that they are using. Does that make sense? So I'm not telling you that if you work as a construction worker, you're going to be using rational functions, because that would just be a flat out lie. And you know I don't want to do that to you. Yeah? But these are some situations where in real life, quote unquote, rational functions can be talked about. Is that fair? Okay. In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in the middle. How much calculations do you think that takes? Yeah, a lot, right? Because even if they're like slightly off, like they're going to totally miss each other, aren't they? Okay, so they have to be real careful of that. Not only at the beginning when they're planning, but as they're creating the tunnel, right? Okay. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? What do you think right now people tell me is the answer? 7. Right? 4 years and 3 years. That should be 7 years. But logically, you know what? It can't be 7. It has to be less, doesn't it? If 2 machines are working at the same time, it should be less than it takes both of them to do it individually, doesn't it? So here's how we set up our equation. Now, you know, because it's rational functions, the way that we're going to set this up is in what? Fractions, for sure, right? Okay. So the first machine can do this one job in 4 years. It's doing one job in 4 years. That's the first machine, right? What's the second machine look like, you think? 1 over 3. Why? It can do the one job, but it takes 3 years. What are we going to do with those two fractions, you think? Why add? They're working at the same time. Okay? What's that going to equal? How many jobs are they doing if they're working together? Still one job, right? And how long does it take them to do that one job? Yeah, that's literally what we're trying to find, right? What do we call that? Yeah, the variable, x. I mean, you can choose another letter if you want, but I just chose x. Is that all right? Now, knowing what you know from yesterday and the day before, what do we do now? We have to find a common denominator, don't we? Now, are we finding a common denominator to get a denominator? Or are we finding a common denominator to eliminate, right? We're going to be assassins again, aren't we? Okay. So what is our common denominator here? Okay, what is it if it's this? 12. What is it now? 12x. If I multiply every term by 12x, what happens to the first term? 12x over 4, which simplifies to what? 12 and 4 simplify to 3 over 1. So I just have 3x. What happens to the second term? So the 12 and the 3 simplify to 4x. And what happens in the last part? Yeah, the x's simplify. We just have 12, right? Does anyone know what 3x plus 4x is? Excellent. 7x, okay? 7x equals 12. How do I solve this? Divide both sides by 7. Are you ready for a conversation? Do you agree that that's the answer? It's the answer, right? That's the answer. We all agree that that's the answer. We got 12 over 7. What the heck does that even mean in the context of this problem? Nothing. It means literally nothing to us. Okay? So we could make it a mixed number, 1 and 5/7, right? What does that mean in the context of this problem? Still nothing. Not much, right? We know it's more than a year. But 5/7? What should we do, you think? Decimal. Go ahead and put it in your calculator and give me a decimal rounded to the 100th. Just as a reminder, you know and I know that our calculators can be smart alecks, can't they? What literally happens, I'm making a new document. No, I don't want to save the old one. What literally happens if I say 12 divided by 7? What a jerk. It's a smart aleck, right? So 12 divided by 7, you can do control enter, or you can hit decimal enter, and that'll help you give you a decimal, yeah? So what are we putting here? 1.71? 1.71 years? Months? What? Years. Now, 1.71 years is in the right direction, and that's the kind of answer that I'm going to want. But I need you to make sure you understand what that means. Correct me if I'm wrong, but this means 1 year and 7 months. So you're correcting me because I'm wrong, right? But guys, that's a really common misconception. 1.7 years does not mean 1 year and 7 months, does it? It means 1.7 years or 71 years. So what does that mean as far as months goes? Well, let's think about this for a second, okay? 0.71 is really close to what decimal that we like. 0.75, right? 3/4, right? Can we think about 3/4 of a year? Well, 1/4 of a year is how many months? 3 months. So how many would 3/4 be? 9. So this is almost 1 year and 9 months. Are you in agreement on that? That makes sense to us in the context of this problem. Is there anything wrong with this answer? Is there anything wrong with this answer? No. But if I really want you to think about it, I might ask for years and months. And would it be okay if for this answer you wrote almost 1 year and 9 months? That would be perfectly fine, right? Because I'm not asking for exact. You already know that when I asked for it rounded to the 10th, right? Good. That's a good conversation that we just had. Okay? Was any of it hard? No, but you had to think about it, didn't you? Okay? Sometimes in math, we have to think. Got it? Okay? I'd like to do one more problem for you on this page, 2, 3, or 4. How about if I do 3? That'd be all right? You are responsible then for 2 and 4 for homework. I know there's a back. I'm the one that made the worksheet. It's okay. Okay? We have to have something to do tomorrow. Okay? So I'm going to do 3, and then you're going to do 2 and 4 for homework. Got it? Okay. Chef Craig can decorate a dozen cupcakes in half the time of Chef Charlotte. Together they can decorate the dozen cupcakes in 8 minutes. How long would it take each chef to decorate the dozen cupcakes alone? So how's this one different? Isn't this kind of backwards of the first problem we just did? The first problem, we knew how much they did individually. We needed to know how much they did together. Now we know how long it takes them together. We got to figure out individually, right? So what do we know? Let's talk about Chef Craig. and Charlotte. Chef Craig decorates faster than Charlotte? Yeah, because it takes him half the time, right? So what if we call his speed x? What's his fraction? 1 over x, right? Well, if we call him x, what are we going to call Charlotte? No. We only want one variable. 2x, right? Because it takes him half the time. Well, that means it takes her twice as long, right? So she should be 1 over 2x because we're still talking about the same one job, right? What are we doing with their information? Adding. And what should that equal? 8. How many jobs are they doing? One job in 8 minutes, right? Okay. What now? Common denominator, what is it? X is part of it. 8, right? So 8x here, here, and here. If you multiply everything by the thing that you think is the common denominator and not all of the denominators simplify away, then you've chosen the wrong denominator. Does that make sense? Okay, so what happens here? X's cancel, simplify, and we end up with 8. What happens here? X's simplify, 8, and the 2 simplifies too, doesn't it? And we end up with 4. And what happens here? 8 simplify, and we end up with, oh my gosh, this is a ridiculous problem, isn't it? 8 plus 4 equals x. Does anyone know what 8 plus 4 is? 12 equals x. Now answer the question, please. How long would it take each chef to decorate a dozen cupcakes alone? So Craig will take how long? What did we call him? X. So how long is it going to take him? 12 minutes. Charlotte? What did we call her? 2x? So 24 minutes. Does that make sense? Guys, I did a really bad job of modeling the answer for number 1. Can we go fix that really quick? Is my answer 1.71 years? It will take both machines 1.71 years. Does that make sense?